Hello learners, I'm here to show you how shear force and bending diagram calculations is done. So here with me I have a question. The question says that draw the shear force and the bending moment diagram for simply supported loaded beam as shown below. So here is the beam. You can see it is simply supported. Here we have an upward force. Again, here we have another upward force. Then we have a downward force, 2 kilonewton. Another downward force, 4 kilonewton, 2 kilonewton. So, guys, the distance from here to here, here it is point A. Then we have point C. Then we have point D. Then we have point E. Then we have point B. So guys, first of all, we are going to look for the reactions. We are going to calculate reactions. So we have reactions. We have reactions at reactions at A and reaction at B. So we need to know the values at this reaction at this point, then reaction at this point. And you all know that reaction at B and reaction at A is equals to these are the upwards, they are the upward forces. So the upward force is equals to the downward force, whereby the upward force, it is a reaction at A and reaction at B. Then the downward force are these these arrows that you are seeing, they are pointing downwards. Those are the downward forces. So we have moment, and you know moment is equals to force times distance. So for we to get, we shall here have reaction at A, reaction at B plus reaction at A is equals to 8 kilonewton. 8 kilonewton, it is 2, this 2 plus this, you will get 8 kilonewton. So that one becomes our equation 1. So the reactions, it is force times distance, that is moment. Force times distance. So reaction at B here, reaction at B. So we shall take that reactions at upward reaction, it is positive. Then the downward reactions, it is negative. So guys, reaction at B here times the distance from here to here. So it is 1 plus 1 plus 1 plus 1. You get 4. So reaction at B multiplied by reaction at multiplied by the distance 4 minus 2. Why are we putting minus? Because it is the downward force, and you know the downward force, it is negative. So that's why we are putting here negative. So it is negative minus 2 times the distance from here to here. It is 1, 2, 3. So it is 3. Minus, again it is downward force. So it is 4 times 2, the distance from here to here. It is 1 plus 1, 2. Minus 2 times 1, that is the distance, is equals to 0. So we have this time this, you get 4 RB minus 2 times 3, it is 6. 4 times 2, it is 8. 2 times 1, it is 1. So reaction at B, so when you take minus 4, minus 8, minus 6, minus 2 is equals to minus 16. So minus 4, so 4RB minus 16 is equals to 0. So when this minus 16 come to the other side, it becomes positive. So it is 4RB is equals to 16. So what do you get? You get RB is equals to 4 kilonewton. But remember, here we say that RB plus RA is equals to 8 kilonewton. So, but now we have RB as 4 kilonewton. So guys, RA plus 4 kilonewton is equals to 8 kilonewton, this one. So our RA will be 8 minus 4, because this 4 now has come the other side. So the sign changes from positive to negative. Okay, so our RA is equals to 4 kilonewton. So RA here, it is 4 kilonewton. Then the reaction at B here, we also got as 4 kilonewton. Now, we want to get now the shear force. We want to find the shear force. So we come and calculate the shear force calculation. So we are also taking as the upward force as positive and the downward force as negative. So shear force at B, the shear force at B, when you come here, the shear force at RB, the shear force at here, shear force. So the shear force will remain as the reaction. We shall take as the reaction of which it is 4 kilonewton. So this 4 kilonewton will remain our shear force here. Then we are coming to get the shear force at point E. The shear force at point E. So the shear force at point E, guys, we shall have the shear force at point E, we shall have as we take the reaction here, the force here, the upward force, we multiply by the distance, of which the distance is 1. Then, sorry guys, we take the force here, the force from here, then we subtract the force from here, this 2 kilonewton, this downward force. So we are coming to take 4 kilonewton minus 2 kilonewton. We get 2 kilonewton as the shear force at point E. Then we want to find the shear force at point D, So we are coming here and say that this 4, we are taking this 4 here, the force, the upward force. We subtract this 2 as the downward force. It is the downward force, and that's why we are subtracting. So it is 4, the upward force, minus the downward force 2, minus the downward force 2, minus the downward force 4. This downward force here, it is that way. So we are taking 4 kilonewton minus 2 kilonewton minus 4 kilonewton. We shall get minus 2 kilonewton. Then the shear force at this point, now we shall have 4, the upward force, minus 2, minus 4, minus 2. That way, so it is 4 kilonewton minus 2 kilonewton minus 4 kilonewton minus 2 kilonewton is equals to minus 4 kilonewton. That one is our shear force. Then we want to get the shear force at point A. The shear force at point A, it will be the upward force 4 minus the downward force 2 minus the downward force 4 minus the downward force 2 plus this one. This, it is the upward force, so it will be positive. So plus 4, because for the force here, our force here, it is 4 kilonewton. So we are coming here, guys, we get 4 kilonewton minus 2 minus 4 minus 2 plus 4, you get 0 kilonewton. So our shear force at point, the shear force at point A, it is 0. So we are done with shear force. Now we want to calculate the bending moment calculation. So bending moment, it is, you come here, guys, bending moment at simply supported beam, it is always at the end side, it is always 0. It is always 0. So our bending moment at point B, it is 0. It is 0. So we want to get the bending moment at point E. So the bending moment at point E, remember, it is force times distance. So the bending moment at this point, it will be this 4 here. Remember, we have 4 here. This upward force, it is 4. So it is 4 multiplied by the distance 1. So it will be 4 times 1, you get 4 kilonewton meter. Now we want to get the bending moment at point D. The bending moment at point D, it is force times distance also. So it is force here 4 multiplied by the distance. Now the distance has expanded from 1 to 1. So 1 plus 1, it is 2. So 4 times 1 times force times 2. So it is 4 times 2. Then minus, remember, we also have here a downward force. The downward force here, its distance is 1. So it is 4 times 2 minus, because it is the downward force, minus 2 times 1. So it will be 4 times 2 minus 2 times 1. Then the answer will be, our bending moment at point D, it will be 6 kilonewton meter. So guys, we are coming to bending moment at point C. So the bending moment at point C, it is 4 times 3. 4 times 3. Remember, 4 times 3. 3. Where are we getting 3? It is 1 plus 1 plus 1. You get 3. The distance has increased. So it is 4 here multiplied by 3, then minus 2 multiplied by 1, 2 times 2, then 4 multiplied by 1. Let me repeat again. It is 4 times 1, 2, 3, 4. So 4 multiplied by 3 up to here, minus 2 multiplied by 2, the distance, minus 4 times 1. So what will be our bending moment at C? It is 4 kilonewton meter. Then the bending moment at point A, it will be 0. Why? Because we said the bending moments at the end of the simply supported, it is always 0. So we are done with bending moment, and we're also done with shear. So we want to draw now, the shear force diagram and the bending moment diagram. So guys, here it is our diagram. Here it is our diagram. So what we will do, it is, we shall extend this line from from point B downwards, also this point, also this point, also this point, also this point. So we are coming to draw our shear force. So we have the line of reference. We'll start with the shear force diagram. So line of reference 0, 0, 0.00. Now, so from what was our shear force? What was our shear force at point B? Our shear force at point B was, you remember, was 4 kilonewton. So we shall go upward 4, up to 4 kilonewton. Then, because here we don't have any force from here, we don't have any force, so it is a straight line. I'll just draw a straight line. Then the bending, the shear force moment at point E was 2. I think you remember, was 2 kilonewton. So we shall come down 2. We shall come down up to 2. We shall count up to 2. So it will be 2 kilonewton. Then from here to here, from here to here, there is no any force. So it is a straight line. Then you remember the shear force at point D was negative 2, was negative 2. So from this point, we shall come up to negative 2. Our negative 2, it is here. So it is negative 2. Then from this point to this, we don't have any force. So it is straight line, straight line. Then the shear force at point C was negative 4. So we shall count from here was negative 2, then another negative 2, it will become negative 4. So it is negative 4 kilonewton. Then from this point to this point, we don't have any force, so it is a straight line. Then our shear force at point A was 0. So we go back to 0. So this one, it is our shear force diagram. So this one here, it is negative, then positive. So we shall shade these points to show that that one, it is our required point now. So from there, we are going to draw the bending moment diagram. Bending moment diagram, from at point B, the bending moment was 0. So it is made with the 0. And this one, we demonstrate, we show using an incline line, an incline line. So from here, it is 0. So then the bending moment at point E was 4 kilonewton. So we at E, here it is our point, it is point E, 4. So we shall go up to 4 using an inclined line. Then the bending moment at point D was 6. So we shall go 2. We shall count 2 because from here it is 4. So we shall go up to 6 kilonewton meter up to here. So it will be 6 kilonewton meter. Then we go downward because it is at point, the bending moment at point C, it was 4 again. So we go back up to 4. Then the bending moment at point B, at point A here was 0. So we shall go back up to 0. So this one, it is our bending moment diagram. So as easier as that. As easier as that. Thank you.